Hey everybody, let me clear this out. Okay. So first today we are answering around the world questions. You guys asked for almost every single one of them, so here we go. Um, Excuse the toys in the background. It's getting really bad. Um, oh well, here we go. Okay, so the first one that you guys requested. So I went ahead and put this um uh, thing in order. So man, it's really hard to see. So that you can see the correct order for the around the world. I started with number one. So I'm gonna go in that order. But I'll post like the hard copy of these solutions when you get a chance, or at the bottom of this box. I don't know what I'm saying. Okay. Number 7. So this was calculator inactive. And I'm probably going to have to flip back and forth between, because I don't have the document printed out. Let me look. Here we go. So number 7, let f prime of x equal sine squared of 2x cosine 2x. Find f of x given that f of pi is equal to 3. To find the next card, look for the value of c. So we're looking for c. Okay, so let's pull all this stuff back up. Oh no, come back. This, and then the camera. Okay, cool. All right, so I've written all that basic information down. Everything that's on the paper right now is just what's given in the problem. Then, so in order to find f of x, we have to integrate. So we're going to find f of x by integrating sine of 2x, and they have the square on the sign. You can rewrite that as pulling the square outside of the sign. So we see that we have a composite function there. Times cosine of 2x dx. So now both of these functions, sine of 2x squared and cosine 2x, are composite functions, but the inside function of one of them, even though it has 2 layers, is the same. And so we want to pick this guy as our composite function, and this is like our derivative. Okay, so this means that our u is going to be equal to sine of 2x, sorry. And so then dx is going to be 2 cosine of 2x. Our du. Where is, oh, there it is. Okay, so that's our du. We have just cosine 2x dx here, so we want to multiply by 1/2 on both sides to get rid of that too. So 1/2 du is equal to cosine 2x dx, just like we have in the problem. I can highlight that. So we were looking to be able to replace this exactly. We have now replaced it with this. That thing is equal to 1/2 du, so we can replace it. So this means that my function is going to be the integral of u squared du. And then when I integrate this, of course, I get 1/3 u cubed plus c. I'm like running out of room. And yeah, I spaced this really poorly. I apologize. I'm going to put my u over to the side so that cosine 2x dx, I can white it out. I honestly should just like totally start over at this point. Because I have like botched this so much, but we're just gonna, whatever. Okay, so 1/2 du is equal to cosine 2x dx. We'll highlight it just like the other one. White this out so that I have less stuff in my way. And I apologize for that. Luckily, you can just skip ahead of my annoying mistakes now. Okay, So now we want to sub u back in. So I'm going to have 1/3. My u was sine of 2x. And then, oh shoot, I forgot my 1/2 right here. 1/2. So that means that when I put my 1/3 there, it becomes 1/6. So that guy should be 1/6 u cubed, okay? Because if I differentiated this, I would want a coefficient of 1/2 right there, okay? And 3 times 1/2, or 3 times a 1/6 is going to give me the 1/2 that I wanted. Okay, so then I would have 1/6 sine of 2x, okay? And plus c. Okay, and then we're also given the information that f of pi is 3. So we know that 3 is equal to 1/6 sine of 2 pi plus c. The sine of 2 pi is 0. So c should just be equal to 3. So this means my final f of x is 1/6 sine of 2 pi plus 3. Okay, but the 3 is what we're looking for on the next card, which leads us to number 6, which is another one that you had questions about. Okay, so in number 6, it looks like it wanted us to find the area between two curves. Let me double check. 8, 9, 10, 6. Let f of x equal x squared minus 2x plus 1, g of x be sine of x squared. Find the area of the region enclosed by the graph of f and the graph of g. Okay, perfect. So this one was calculator active. Yay, we can use our calculator. And so when we graphed these, you should have gotten like part of a sine curve and then a parabola, and then these two intersection points that we wanted to identify. And you should be able to figure out that the first intersection point is 0.501 and the second intersection point is 1.65. Okay. So those are going to be our limits of integration. So 0.501 is smaller than 1.646. So we're going to use that one on the bottom and then the other one on the top. Okay, and then we're going to take the top one, which happened to be the sine function, and subtract the bottom one from it. Do not waste any time putting this down algebraically. Stick it straight in that calculator. Don't even simplify. So let me show you. Okay, so you're going to go to y equals, and you're just sticking sine of x squared minus, put your parentheses, so you don't even do any algebra in your head, minus 2x plus 1. Oops. Okay, so you have our quadratic function in parentheses, a difference, a subtraction sign, and then your sine of x squared first. Graph it. It'll graph both. First it's gonna, okay, so because we didn't like graph them separately, we our picture is gonna look different, and what it's gonna do is find the basically the area between these two roots right there, because those two roots are where the difference of the two functions are 0, because that's where they intersected and they had the same value. So now we're doing second trace to get our calculate function, going down to the 7th option to do our integral. Our lower limit is 0.501. Our upper limit is 1.65. And then we should get that our integral is about 0.695 units squared. So this would be our final answer. So with this one, it's not that tricky because it's calculator active. Don't even worry. about doing any algebra with this. Utilize the calculator active function, okay? Next was number 2. And in number 2, I think there was nope, not a specific question. We'll just do it. Okay. This one was not calculator active. And let's see what the actual question asked us. I really should have just printed this out. Okay, so it says no calculator, let f of x equal cosine x from 0 to 2 pi. The region R is enclosed by that in the line x equals b, where b is greater than 3 pi over 2 and the x-axis. The area of R is that. Find the value of b. Okay, so our area of R was 1 minus root 3 over 2. Okay, let me switch back. Okay, so in number 2, basically we're setting up an integral, but our variable here is b, and b happens to be one of the limits of integration. And we know that it's something bigger than 3 pi over 2, which is our lower limit. So that means that b has to be our upper limit. That was like what they were getting at when they told you that. And then we're integrating cosine of x dx because that's the function that they gave us. And we know that that integral should give us 1 minus root 3 over 2. Okay, so we're going to have to do the algebra here, but it's not so bad because the integral of cosine is just sine. So this should be equal to sine. I'm going to sub in my upper limit first, b minus sine of 3 pi over 2. And this is going to be equal to sine of b, because